Hello students, so last week we stopped until here and today we are supposed to do some of the question. So before I start, let us do some revision about what is exothermic and endothermic. Okay, so let's do a bit of recap. This one we always must remember. Exothermic is released, heat is released to the surrounding. For example, I will usually remember like this first. This is the number one I remember. Heat is released and a rise in temperature. Means the temperature will go up. Whether 0 to 100, 99 to 100, 97 to 98. Means the temperature is ascending. Rise lah ascending. Like max lah ascending. As long as whatever temperature it go up, so it is exothermic. Endothermic is heat is absorbed. Heat is absorbed, so there is a drop in temperature. So I will consider this as descending. Descending means 100 to 99, 70 to 60, 70 to 40. So these are descending. Okay, so now it comes with a $1 million question. If exothermic say hot, means heat is released like burning of rubbish, burning of food, cooking, heat is released. Then I understand that the temperature rise. Usually the thing that come confused is when they say heat is absorbed. Because usually not only student will think, the teacher also will think. For example, sometimes also I will think like, heat absorb ma. If I absorb heat, not I become hot, meh? Correct or not? Because I absorb heat ma. If I absorb heat, then I become hot lor. Then why is it say that the temperature become cold? Because endothermic means it become cold. So why heat is absorbed from the surrounding, but the temperature become cold? Okay, so the keyword is to the surrounding. This is keyword to the surrounding. Okay, let's do the heat is released to the surrounding. Let's see if I got some empty space here or not. Okay, I got some empty space here. Okay, let's draw exothermic so that we can understand. Heat is released. Heat is released means there's an increase in temperature. Why? Assuming that we are talking about heat is released to the surrounding. You know what is surrounding or not? This is surrounding. So now surrounding me. Okay, there's a surrounding. Okay, so for example, like let's say I draw a cup of hot water. So I just draw like that, and this is the water hot lah. Or I boil the water. Okay, I boil the water. Then the heat is released to the surrounding. You know what surrounding? Surrounding means the air. So if I put a thermometer here, even I put outside here, I put a thermometer, there is rise in temperature. Showing that this is actually an exothermic process. Okay, let's say I want to make the water become ice. How to make the water become ice? You put the water in the refrigerator, right? If you want the water to become ice, so you just put inside the refrigerator. So what happens when you put in refrigerator? So let's say this is a cup of water. And I put in the refrigerator. So eventually, this one, it will become from water, it will become ice. Right or not? Water, it will become ice. Why from water it become ice? Because you can see here, heat is absorbed. Okay, now this is the confusing part. I'm not saying heat is absorbed by the water. Because if I say heat absorbed by the water will become very hot. As we can see here the heat is absorbed in water. Okay, that is why when the question start to be confused, either you want to talk heat absorb, the water absorb heat, or the surrounding absorb heat. From here, exothermic, we can see that the water absorb heat from the fire. So the water become hot because the water absorb heat from the fire for using conduction process, if you still remember or not. Conduction, convection, radiation. So water receive its heat from the fire. Surrounding absorb the heat from the water, or the water release heat to the surrounding. That is why the definition say heat release to the surrounding, not heat release to the fire, or you get what I mean or not? There's a difference. Or I didn't say the surrounding release heat to the water. And it is same at here. Water become ice, so now heat. The question is, water absorb heat or surrounding absorb heat? I cannot say like that. I must say like this. Water absorb heat or water release heat. Because if water absorb heat, the water become hot. Water release heat, water become cold. Get what I mean or not? Because we know that cold is not energy. Cold is just a absence of heat. So either you want to absorb heat or you want to release heat. We already covered in the previous video. So for here, because water become ice so water cannot absorb heat. Water must release heat to who? To the surrounding. That is why I say here, heat is absorbed from the surrounding. So I can actually say two things. Depend on you lah, which one you want to say. First thing I can say, heat is absorbed by surrounding. So I can say heat is absorbed by surrounding. Or I can say heat is released from water to the surrounding. Right or not? Is it still the same thing? Still the same thing. That's why when students start to confuse when the question say absorb, release, we need to read the question. Where you are talking about surrounding to water or water to surrounding. It's not about absorb or release, because students tend to exothermic means release it. So they just remember like that. But when the question didn't say exothermic, they just give you a sentence, the students start to question mark. What I thought release means exothermic. Yeah lah, release is exothermic if release to surrounding. But I say release from water to the surrounding. You see or not? You see the difference or not? So I can either use absorb or release. Or this one, for example, I can say that, where's my pencil? Wait, my computer a bit lag. So we can see here exothermic heat is released to the surrounding. So I can say that heat is released to the surrounding. Or I can say heat is released, heat is absorbed, heat is absorbed. Can I say heat is absorbed from the fire? I will say lah, I will say like this lah. Water absorb the heat that comes from the fire. Correct or not? Water absorb the heat come from the fire. If water don't absorb the heat, then how the water become hot? But heat is released to the surrounding. because the surrounding later, the temperature of the thermometer become hot. Yeah. So later, don't worry. If you don't understand, don't worry. We will do some exercise for this question. But there's a few questions that always I do in science. The question didn't state it clearly. And this actually confused the student, because not only confuse the student, it confuse the teacher. If the question is not given clearly, they just give you a picture of a water boiling. Usually it's exothermic but if they don't give you a picture, sometimes they give you cooking or pan. You want to ask about the pan or you want to ask about the egg? This is the confusing question that you are talking about, because the pan absorbs heat from the fire. And then you're talking about egg, means the egg release heat to the egg, something like that. So this is the unclear question from the workbook, which I always happen to find, especially for this chapter. But if I see the book got problem, then I just tell the book got problem. Yeah, so this is the thing. Let's do the question. Let's just stop at here. What is this thing? Okay, the hypothesis of the experiment accepted. What is the conclusion of the experiment? We already done this in the previous video. What is the operational definition for the release of heat in this experiment? Okay, so what is the operational definition? Operation definition is how to say usually if you know English, right, we always say definition of the word, because definition what is the definition for a book? Okay, a book is a power of paper for people to read, for example. Operational definition is more towards the more specific, because towards this experiment, rather than you go to dictionary, you find the meaning. Okay, it's more the specific towards certain category. For example, this one is for the experiment. So for this experiment, I can say that there is an increase in temperature in exothermic, increase in temperature. So what is the operation definition? So I think it will be exothermic, the rise in temperature. So where is my what's the operation exothermic for release of heat? Okay, exothermic. So I would say is the release. Should I say release? Release of heat to the surrounding. Yeah, no, I just say the rise the rise in the temperature. Because in this experiment, we can see that if there's rise in temperature, then it's exothermic. The rise in temperature, maybe I just add due to release of heat to the surrounding. This is insurance Get I wrong, right? So I type more. Sometimes science like that, If you put more, sometimes you're behind correct, the teacher will still give you correct. Because behind correct I didn't say wrong And if you put in front correct I didn't say wrong. In science So if I scared, sometimes I just put two answer. Someone already put exothermic. I almost put everything in it already. What is the absorption of heat in this experiment? So maybe I can say is endothermic. Right, where is my endothermic? The decrease in the temperature due to heat is released to the surrounding. So very important this word surrounding. Very important Surrounding means the surrounding How about surrounding your air usually? Because if you just say heat is released, heat is absorbed, then it doesn't really mean anything. You absorb from where? From the surrounding, or you absorb from the fire? You get what I mean or not? Because the water become hot because the water absorbs heat from the fire. And then the water become cold. because heat is released to the surrounding, correct or not? Because if I put in vacuum, the water become hot faster because there's no heat can be released in the vacuum. I mean, it's not no heat, but it's very difficult for the heat to release in the vacuum. But when you put in wind, I put the fan and I boil, the water boil slow because I got put the fan ma. But the water absorb heat from the fire, but the wind absorb the heat from the water because you open the fan and the fan blow the heat away. Okay. What happens when the temperature shown in the thermometer is at maximum or minimum? Just put both. Either you put the reaction or substance has reached thermal equilibrium. Oops. Okay, the reaction or the substance have reached thermal equilibrium. So because they ask what happened. Hey, explain your answer in 2A. Sorry, then I think this answer should be here. The reaction has reached thermal equilibrium. Okay, so I think for 2A, I will choose this answer. The temperature will be at stagnant because stagnant means stop lah. Maximum it will stop for a while. No matter how long you wait, because at first you wait ma. You wait, and then the thing will stop at there. Or you wait for it to be cold and it will stop at there. So it will stop lor. Or why the reaction has reached thermal equilibrium, or you can say the reaction is already finished, or the substance for the reaction already been used up. What happened? You can say that the temperature will be stagnant, or maybe you can say that the substance already been used up. There's a few answers lah, huh? Okay, so if no question, let us continue. Okay, question. That's why when science, there's a few answers. This is the complicated one because how to say, it's difficult lah because when they ask, then but we don't know what the question want to ask, and there's like a few answers. And how to know the real answer is only by doing a lot of exercise and looking at the marking scheme. If the marking scheme right like that, then it's like that. That's why we do more practice in the science. State the criteria used in the experiment to classify the reaction as exothermic and endothermic. Okay, so for this one, maybe I will say exothermic temperature during reaction rises. Endothermic temperature during reaction, it will drop. And I just accidentally find the operation definition because I got the textbook here. Not a textbook, it's just a revision book. So maybe I just can copy this. Okay, so these are the definition that I can copy from a book. Okay, in the experiment, the operational definition for heat change is blah, 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 blah. Okay, release of heat means temperature action rises. So it's the same lah as what I write here. I think it's almost the same, but I just copy for you to refer lah. Depend on which one you want to follow. Okay, list the exothermic reaction in this experiment and list the endothermic in this experiment. So think, list the exothermic reaction. So exothermic reaction, let me list it out. Exothermic is, this thing blocked me. I delete this thing. Exothermic is sodium hydroxide and water put N, hydrochloric acid and sodium hydroxide solution. So this is exothermic. Endothermic is ammonium chloride, salt and water, hydrochloric acid and sodium hydrogen carbonate is endothermic. How can the accuracy of the maximum minimum temperature be increased? Okay, so this one you need to think this is the K-BAT question. Because when you increase the temperature, the temperature won't go that high because heat is lost. Correct or not? Due to it's called the conservation of energy. Not conservation of energy, heat is lost. You get what I mean? For example, maybe you do your experiment in the aircon room. So because you do your experiment in the aircon room, those science lab there's no aircon, but maybe your school very rich lah, so got aircon. So the heat is lesser compared to if you do without the aircon. So your answer that you get in experiment might not be that accurate. So in order to make it more accurate, 比较准啊, more accurate, what you must do? Okay, so my student say repeat the experiment. Yes, when you repeat the experiment, you will get more accurate reading. Repeat the experiment. But I think to be more accurate, you can use lag. Use lag. Okay, or you can say use lagging. Use lagging to prevent heat loss. I think, because I think for your answer for SPM, the answer is put a cover on the cup. I think this for SPM is this one. Put a cover on the cup. Because the heat loss, because the wind can blow. So what you can do is you put a cover, close it, so that there won't be a reduce the heat loss. Okay, for SPM. For PT3 PT3 SPM. This one use lagging actually is also true. It's actually, but I think it's for IGCSE. Because I'm teaching IGCSE also. Actually, it's quite similar. But lagging means like that. I put something to block it here. Lagging. Maybe I put cotton, and then I just take something to wrap the cotton. So the heat loss from the cup is lesser. So of course, it's the best if you do like this. Okay, you use lagging and you close the lid. So by doing so, you can increase the temperature and it will be more accurate. Repeat the experiment also is true, but I think it's more towards consistency. Means you repeat how many times also the temperature will be 37, and your experiment will be more consistent. But if you use the lagging and the cover, the temperature will increase, which actually answer the question because the question is asking about accuracy. Explain your answer in 6A. Okay, so maybe the answer we can say to prevent heat loss to the surrounding. To prevent heat loss to the surrounding. Correct or not? You prevent the heat loss, then you get more accurate reading. So, yeah, I hope you don't will take a long time to explain this experiment, but most questions actually ask from this. Actually, this one is more difficult than the question that might ask in PT3, which is good. We already did it. And I see you next video about example of exothermic, endothermic. Okay, so see you then. Thank you and bye-bye.